Diving deep into scikit-learn feature selection, a comprehensive guide. Scikit-learn's features election module offers a powerful toolkit for selecting relevant features from your dataset, improving model performance and reducing complexity. Let's dive deep into its intricacies. 1. Why feature selection? Improved model performance. Irrelevant or redundant features can confuse your model, leading to reduced accuracy, increased training time, and overfitting. Feature selection eliminates this noise, leading to better generalization and prediction. Reduced complexity. A smaller set of features makes your model easier to understand and interpret, facilitating insights into the underlying data patterns. Enhanced efficiency. Less data means faster training and deployment, particularly important for large datasets. Improved robustness. Feature selection can mitigate the impact of outliers and noisy features, making your model more resistant to variations in the data. 2. Types of feature selection techniques. Filter methods. Univariate feature selection. Evaluate individual features based on their relationship with a target variable, regardless of other features. Chi-squared test for categorical features measures the independence of features from the target variable. ANOVA F test for continuous features tests the difference in means between groups defined by the target variable. Mutual information measures the dependency between features and the target, capturing both linear and nonlinear relationships. Select K best selects the top K features based on the chosen scoring function. Select percentile selects a certain percentage of features based on their score. B wrapper methods. Recursive feature elimination. RFE recursively removes features based on the performance of a chosen model, e.g., logistic regression, SVM, until a desired number of features remain. Sequential feature selection. SFS iteratively adds or removes features based on the model's performance, considering combinations of features. Forward selection starts with an empty set and adds features one by one. Backward selection starts with all features and removes them one by one. C embedded methods. Regularization techniques penalize the model coefficients for complex models, effectively shrinking the weights of less important features towards zero. Lasso L1 regularization imposes an absolute value penalty, driving coefficients of less relevant features to zero, effectively performing feature selection. Ridge L2 regularization imposes a squared penalty, shrinking coefficients but not driving them to zero, primarily used for reducing overfitting. Decision tree-based methods. Tree-based models like random forests naturally perform feature selection by prioritizing features with greater predictive power. Feature importance scores features based on their contribution to reducing impurity in the tree. 3. Feature selection in scikit-learn. Features election module contains various methods for feature selection, categorized as filter, wrapper, and embedded techniques. Select K-best class for selecting the top K features using various scoring functions, e.g., chi-squared, ANOVA F test, mutual information. Select percentile class for selecting a specific percentage of features based on their score. RFE class for implementing recursive feature elimination using a chosen model. Select from model class for selecting features based on the importance scores learned by a model, e.g., lasso, random forest. 4. Implementing feature selection. Python. From sklearn, features election import select K-best. Cheat 2. From sklearn, model selection import train test split. From sklearn, linear model import logistic regression. Load your data. X, Y. Split data into training and testing sets. Xtrain, Xtest, Ytrain. Y test train test split X. Y. Test size 0.2. Random state 42. Select top 5 features using chi-squared test. Selector select K best chi2. K5. Xtrain selected selector. Fit transform Xtrain. Y train. Xtest selected selector. Transform Xtest. Train a logistic regression model. Model logistic regression. Model. Fit Xtrain selected. Y train. Evaluate the model's performance. Score model. Score Xtest selected. Y test. Print F accuracy score. 5. Best practices. Understand your data, analyze the distribution of features, their relationships with the target, and the presence of outliers. Choose appropriate techniques, select methods that align with your data type, model type, and desired outcome. Consider model interpretability, choose techniques that facilitate understanding the selected features and their impact on the model. Validate your results, evaluate the performance of the model with and without feature selection. To ensure improvement, beware of overfitting. Feature selection should be applied to the training set and not the testing set to prevent information leakage. 6. Additional considerations. Feature engineering. Sometimes creating new features from existing ones can improve performance more effectively than simply removing existing features. Feature interactions. Feature selection should consider the relationships between features, as selecting one feature might render another redundant. Dimensionality reduction techniques like principal component analysis (PCA) can reduce the number of features while retaining information. Complementing feature selection. 7. Real-world applications. Medical diagnosis. Selecting relevant medical parameters for accurate disease prediction. Fraud detection. Identifying suspicious patterns in financial transactions for fraud prevention. Image classification. Choosing informative pixels or regions for image recognition tasks. Text analysis. Selecting keywords or phrases for sentiment analysis or document classification. Feature selection is a powerful tool that can significantly impact the performance and interpretability of your models. By understanding the different techniques and applying them strategically, you can build more accurate, efficient, and reliable models that extract valuable insights from your data.